Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2024. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure that this book is in front of you when you're working with me. Today we'll solve some problem that you will find on page number 87 and 88. There were two problems that are left on page 87. We stopped yesterday on page 87. We did not finish it because that marked the end of the easy questions. For those of you who actually have the book in front of you, you will know what I'm talking about. Question number 87, according to the people who give the exam, that was the end of the easy questions. And today we'll start the medium questions, starting with 88. So we'll do the two questions that are left over on the previous page, page number 87, and then we'll carry on with 88, page number 88. Let's begin. The very first problem that you can see, as you can see, is already on the blackboard. I'm going to read it to you. I'm going to get out of the frame, pause the video and do it yourself as always, and then compare your work against the work that we'll do together, as I always remind you. So here we go. We are being asked to convert 2.3 times 10 raised to 14 inches into kilometers. And this is given to us in the problem. We are told that 1 kilometer approximately equals 3.9 times 10 raised to 4 inches. Go ahead and do it yourself. Let's see what we can do. Set it up as a proportion problem, inches and kilometers. Inches and kilometers, and we know 2.3 times 10 raised to 14 inches equals, that's what we have to convert, so let's call it x kilometer. That's the unknown quantity. We don't know how many kilometers that is. That's the whole point. But we do know that 1 kilometer goes at the bottom. 1 kilometer we are told equals 3.9 times 10 raised to 4 inches. There you go. That's all it is. We just have to solve for x, inches and kilometers. As long as we pay attention, 1 kilometer equals 3.9. The question is, how many kilometers is this quantity? We want the x, to bring the x over there, bring this on the bottom, and that's all it is. Which means that x is equal to this quantity, 2.23 times 10 raised to 14 over 3.9 times 10 raised to 4. And keep in mind that they're looking for approximate answer. You don't have to be exact, accurate, wasting your time away. They're looking for approximate answer, which I forgot to tell you in the beginning, but that's what it is. It says it is approximately how much? 1 kilometer converted into kilometers, and what's the approximate answer? Let's carry on then. So we see 10 raised to 4 on the bottom. I see 10 raised to 14 on the bottom. Let's divide top and bottom by 10 raised to 4, so the 14 becomes 10. And since we're looking for the approximate answer, what we're going to do is, instead of wasting our time with 2.3 and 3.9, let's convert this. Well, before we do that, and instead of making it too complicated, so we have done this part. Let's multiply top and bottom by 10. Let's multiply top and bottom by 10, so that becomes 23. That becomes 23, which we're going to approximate as 24. And that becomes 39, which we're going to approximate as 40. Times, this quantity remains. This quantity remains intact. We have not done anything with that. That's 10 raised to 10 remains. There we go. We're almost there. Divide top and bottom by 6. So that's a 4, and that's a 10. No, that's not a 4, that's a 6. 6 4s are 24. 6 over 10 is 0.6. So what we have so far is 0.6 times 10 raised to 10. 10 raised to 10. Remove the decimal point and it becomes 6. It becomes 6 times 10 raised to 9. And that's your answer. And that is one of the answer choices you will find that is given to us. Next one, number 89. In number 89, this is what is going on. We are told that the small m equals the mean of first 10 positive multiples of 5. And we are told that capital M equals median of first 10 positive multiples of 5. Same thing. Question is this. Question is quite straightforward. The question is, how much is the median minus the mean? One more time. The small m represents the mean of the first 10 positive multiples of 5. Capital M represents the median of the first 10 positive multiples of 5. The question is, what is the difference between the mean and the median? Go ahead with yourself. Here we go. So the trick here is that if you were sitting there and you wrote out all 10 numbers, which is fine and dandy, but it's not necessary. What we have to understand is that because we're talking about mean and the median, and they're talking about 10 of them, which is an even number, just make up a smaller even number. Just make up a smaller even number, maybe 4, maybe 6. Obviously, it'll be silly to go up to 8. I'm just going to make up 4. So instead of 10, we're just going to work with 4. So as far as we're concerned, mean of the first 4, 5, 10, 15, and 20. The reason we don't want to do 5 is because if we do 5, then the median and the mean, everything falls right in the middle. Maybe you're missing something. So if we do this thing, in this case here, the mean, how do we find the mean? We add them up and divide by 4, which if you wanted to, you could do that, but because they're consecutive numbers, exact multiple of 5, they are consecutive. 5, 15, 15, and if you did all the work, what you will find is the mean is simply the mean of these two. The mean of these two is 25 divided by 2, the mean is 12 and a half. And how do you find the median? How do you find the median when you have even number of numbers? Well, the exact same way. When you have 4 numbers and you want to find the median, you take the average of those two, average of the middle two. It's the same thing. And therefore the answer is big fat 0. Because the mean and the median is the same. The mean and the median is the same. There was no need to make up 10 numbers. Making up 10 numbers would just be a waste of time. Now if you had made up 5, nothing would have changed. If you had made up 5 numbers instead of 4, if you had made up 5 numbers, in that case the mean would have been 15, median would have been 15. The answer is 0. Number 90. Number 90. So now we are officially on the next page, page number 88. Number 90 would require some thinking. Put your thinking cap on. We are told that we surveyed 200 people. Of the 200 people that we surveyed, 60 of them said that they do skiing. They do skiing. We're going to use letter S to represent skiing. 80 of them said that they do kayaking. We're going to use letter K. Now in the problem itself, actually, again for those of you who have the book, they talk about skiing and skating. As you can see how annoying that is. Skating, you could use K for skating, but I just decided to use a different sport. We are further told the number of people who neither ski nor kayak is equal to 2 times the people who do both. Here's the question. How many people do neither? One more time, I'm going to read it to you. So 200 people were surveyed, 60 of them they said they do skiing, 80 of them they said do kayaking. We are further told the number of people who do number of people who engage in neither of these two sports is exactly 2 times the number of people who said they do both. Pause the video, do it yourself. As you can see, this problem clearly calls for Venn diagram. It makes life much easier to portray this thing in Venn diagram, which is what we are going to do, and for that we need the room. So make up a nice Venn diagram. I'm going to erase all of it so we have a nice Venn diagram and I still have room to do the work. So let's call this skiing, let's call this kayaking. This is our universal set. And let's begin, shall we? The question was, how many people do neither? Let's start with this thing. Let's call this x. X represents, let's start from the beginning actually. Let's start from the beginning. I started in a very awkward way. That's going to cause confusion. We are told that 60 people do skiing. Let's put that here. 60 people do skiing. And we are told that 80 people do kayaking. Of course, these 60 people who do skiing and 80 people do kayaking, there are a number of people who do both. Let's call that quantity x. As soon as we introduce that x, we need to subtract that x from here, because we cannot double count them. So the number of people who are left who just do the skiing is 60 minus x. Similarly, this is 80 minus x. So far so good. Now what goes down here? This represents the number of people who do both. What is remaining is the people who do neither. People who do neither, we are told, is 2 times the amount of people who do both. That was the important part. We were told the number of people who do neither, which is x in our case, number of people who do neither is 2 times the number of people who do both. Very good, that's the setup. Once you have this setup, the rest is very easy. The rest is downhill. All we have to do is add them all up, and everything has to add up to 200, because that's how many people we had. We surveyed 200 people. So let's do that. So the number of people who do skiing only, so now it represents skiing only, which is 60 minus x. This is skiing only, plus the number of people who do both, which is x here, plus the number of people who do kayaking only, which is 80 minus x, plus the number of people who do neither, which is 2x. It all has to add up to 200. It all has to add up to 200. It's a very straightforward, very simple linear equation, obviously. Add them up and see what happens. You see that there is a negative x here, there is a negative x here, and then we have positive 2x. So this positive 2x will take care of this negative x and this negative x. 60 plus 80 is 140, plus this x right here, and that has to equal 200, which means x must be 60. But don't be hasty, that's not our answer. 60 represents the number of people who do both. Question was how many people do neither. The answer is 2 times x. So the answer is there are 120 people who engage in neither of these two sports out of the 200 people. Do you understand? That was number 90. 91. In 91, we have given some mathematical operations between different quantities. We were told that when we perform some operation between the quantity m, and the operation is this operation here, whatever the operation is, we don't have to worry about it, whether it's addition or subtraction or division, it doesn't matter. The question is, when we perform this operation between these two quantities, the result is n. Similarly, when we perform the same operation between n and r, the result is m. When we do the same operation between n and q, the result is q. When we do the operation between p and q, the result is p again. And finally, when we do same operation between q and p, the result is r. And here is what we are asked to find. M operation p, operation q, and then operation p. And the answer choices are M, N, P, Q, and R. Those are our answer choices. This is the R. Go ahead and do it yourself. Let me just make sure I didn't make a mistake. M and P, then Q, then P. MP equals N, NR, NQ, PQ, and QP. Go ahead and do it yourself. Pause the video. Let's do it together, shall we? I should have left some room for myself. I did not. Here's what I'm going to do. Let's start here. Let's make a fuss. M operation P. M operation P is this right here, the very first one, and that results in N. So we're left with N operation Q, and then operation P is outside. So now we have to figure out this one. N operation Q is this one right here. N operation Q results in Q. That's the second one. So this ends in Q. And then operation P. I meant to do this. Operation P. And Q operation P is right here. That's the 3. Q operation P results in R. There you go. Looks like the answer is E. It doesn't look like it. It is E. The answer is E. Number 92. Number 92. In 92 we are told that we're going to rent a car and the cost of renting is X dollars for the first 24 hours to rent a car. Then we have to pay Y dollars for each additional hour. The question simply is, what is going to be the cost for 36 hours? What is the cost of renting this car for 36 hours? Go ahead, do it yourself. It's very straightforward, very simple. There's not much to do there at all. For the first 24 hours, we're going to pay X dollars. But we want to drive it for 36 hours, which means we're going to drive 12 additional hours. And for each additional hours, we have to pay Y dollars. There you go. That's all it is. That's how much we're going to pay. Number 93. We are told that the mass of 1 cubic centimeter of a substance is 7.3 gram. We have some substance. What it is they don't tell us and we don't really care. What we do care is that the volume of 1 cubic centimeter of this substance weighs 7.3 gram. Here's the question. The question is, what is the mass in kilogram of 1 cubic meter of this substance? Go ahead, do it yourself, pause the video. That substance looks horrible. I'm going to rewrite it, it's bothering me. That's worse. Let's begin, shall we? Remember, 7.3 gram or 1 cubic centimeter. The first thing is to figure out how many cubic centimeter are in 1 cubic meter. That's very straightforward. 100 centimeter make 1 meter. I hope you knew that. 100 centimeter make 1 meter. We're not interested in meter, or for that matter, we're not interested in centimeter. We are interested in cubic meter and cubic centimeter. So, cube the both sides. Now, 1 cube is just 1, we end up with 1 cubic meter on this side. And 100 raised to 3, 100 raised to 3, and this baby step that I'm about to do, I hate doing it, I shouldn't have to do it. This is the baby step, this is 10 raised to 2. 10 raised to 2 raised to 3 is just 10 raised to 6. And this becomes cubic centimeter. In other words, 1 cubic meter is 1 million cubic centimeter. Now we're making progress. Well, if 1 cubic centimeter, we are told, weighs 7.3 gram, if 1 cubic centimeter weighs 7.3 gram, we are not interested in 1 cubic centimeter, we are interested in a million of them. So multiply both sides by a million. And that's our answer. We just have to work on it. Let's work on it. But another problem is that all of this thing as it is written, we are dealing with cubic centimeter and we are dealing with gram. The question was, what is the mass of this substance which has a volume of 1 cubic meter in kilogram? We'll deal with that later. Let's continue with this thing. So that's our answer. This is our answer here. And this is in gram. Right here, this is in gram. So let's write it here. 7.3 times 10 raised to 6 gram is what we're dealing with. And that is our answer. We don't want it in gram, we want it in kilogram. So let's convert this into kilogram. And we know that 1 kilogram is made up of 1000 gram. Now we're getting someplace. Gram will drop out, we are left with kilogram. In other words, we have to divide this quantity by 1000. Very straightforward. Get rid of the 1000, divide top and bottom by 1000, and this 6 will become 3. And what we are left with is 7.3 times 10 raised to 3. Instead of writing in scientific notation, if you write it straightforwardly, we'll end up with 7,300 gram. Remember, we have a gram, or kilogram rather. We have a kilogram now. The gram dropped out. That's not a gram, that's a kilogram. So the answer is, this object weighs 7,300 kilogram. That was number 93. And I think I'm going to stop here. We'll meet again tomorrow and we'll pick up the second column of this page and we'll continue our story, okay? If I were to do the entire page, it becomes too long. It just becomes too long, the video. I don't like it. We'll meet tomorrow, okay? Bye now.